In this video, we're going to look at the relationship between acceleration and distance traveled. So imagine you're standing on top of a building and then you drop a cannonball. So when time equals 0, the cannonball is here. 1 second later, the cannonball is here. And another second later, the cannonball will be here. And when t equals 3 seconds, the cannonball will be here. When t equals 4, the cannonball will hit the ground. So you're on Earth, so gravity is 10. So on the moon, gravity will be different, round about 2-ish. So gravity is really an acceleration. So really, you're looking at an acceleration of 10. But forget about acceleration for the time being. Gravity on Earth is 10. So what that means is, if you have an acceleration of 10 or gravity of 10, what it means is that your speed increases by 10 every second. So here the speed, when you first drop a cannonball, it won't have a speed. The speed will be 0, and then 1 second later the cannonball will be here. So the speed here will be 10. Because when you have an acceleration of 10 means your speed increases by 10 every second. So when time equals 2, your speed will be 20. That's what acceleration means. It means that your speed increases by 10 every second. Well, anyway, another second later, your speed will be 30. And by the time it hits the ground, your speed, the speed of the cannonball, will be 40. And then if we want to work out the distance traveled, we would use this formula here. So when time equals 1, so the cannonball would be here. This distance here would be you putting the 1 into this t here. So we would use this formula to work out the distance traveled. So it would be, put the 1 into the t, it would be 1 squared, and then gravity, this g here, put 10 into the gravity. So that would be times 10, and then you divide it by 2. So hang on. So this h here represents the distance traveled. So 1 squared would be 1, times 10 would be 10. So this whole thing here would be 10, and then over 2. So the distance traveled after 1 second, is 5. The distance traveled when time equals 0, it would be 0. There is no distance traveled when the cannonball is here. 1 second later, it would have traveled 5 meters. And then when time equals 2, the distance traveled, hang on, let me just clear this up. So when time equals 2, this is the distance traveled here. So we would use this formula to work out the distance traveled. So put 2 into the formula. Put 2 into this t here, because when time equals 2, so 2 squared, and then put 10 into gravity here. So that would be times 10, and then divided by 2. So now this thing here would be 4, times 10 would be 40, and then divided by 2. So it's 40 over 2. So the distance traveled would be 20. So when time equals 2, the distance traveled would be 20 meters. When time equals 3, hang on. When time equals 3, the cannonball would be here. So that means to work out this distance here, we would use this formula here. Put 3 into the t. So put 3 into the t. You've got to square it, and then you've got to times it by 10, and then divide it by 2. So this thing here, oh, what's this? Should be squared because of this thing here. So 3 squared would be 9. 9 times 10 would be 90. So the numerator would be 90. And then 90 divided by 2 would be 45. So the distance traveled would be 45 meters. So this distance here is 45 meters. Anyway, when time equals 4, hang on. When time equals 4, if you want to know this distance here, which is like the height of the building, you would put 4 into the t. So that would be well, put 4 into the t, and then you square it, and then you times the gravity, which is 10, and then you divide it by 2. So this thing here would be 16. 16 times 10 is 160, and then divided by 2, so that would be 80. So d, when time equals 4, the distance traveled would be 80 meters. So this distance here is 80 meters. It turns out to be the height of the building. So you could say the height of the building is 80 meters. Well, anyway, when you have an acceleration of 10 or gravity of 10, because gravity is acceleration, when you have an acceleration of 10, it means that your speed increases by 10 every second. And the distance traveled would be this weird relationship here. Well, we would use this formula, and then in the future we would try and understand where this formula comes from. For the time being, the distance traveled is given by this. The speed for any given time will be given by this. Okay.